Skin depth. S- What is skin depth? When an alternating current is passing in a conductor, what happens? The current is not uniformly distributed in the conductors. Let us say this is your conductor, it won't be uniformly distributed, but displaced towards the surface. So the orange shaded regions or the region where current are passing. You can just look at the center region is white. That means there is no current in that region. It is just concentrating, towards the surface. This is the conductor surface. All are trying to concentrate towards the surface. If you increase the frequency, if you maintain high frequency, that means the alternating current frequency is high. What will happen? Most of these AC signal will pass in the close to the surface, or all the AC signal will be concentrated in close to the surface, or all the AC signal will be displaced towards the surface. So this white region, right? This white region is not having any AC signal. That's what it means. Only the orange regions, the AC signals are propagating or passing. So this is at the high frequency, right? So basically, if you look at this figure, in the DC current, the whole conductor's signal will pass, right? The entire conductor signal will pass, right? So that means if you take the AC current, which is having a low frequency, this is the surface. From the surface to interior, it will uh, pass. That means the depth of this, the low frequency AC current is more. That means from the surface towards the core, this is the core, right? So this is the core. Towards the core, the depth or distance over which the AC signal penetrates is more. So the total distance that penetrates from the surface towards the core or inside the material is called as the skin depth. That means how much the AC signal that has passed from the surface to the core, towards the core or interior. So that distance or that depth, we call it as the skin depth. So this skin depth depends upon the AC current frequency. For the low AC current frequencies, this depth will be larger, right? So the depth will be larger. So for high frequency AC current, the depth is smaller, right? You can just see that shaded regions. This is larger for this is smaller for the high frequency. So that means at high frequency, most of the AC signals are concentrated close to the surface rather than inside the material. So this is the characteristics of the AC signal when you try to pass through the conductors. Now we will see what is this distance, skin depth distance, or what are the factors that dictates the skin depth, right? So what are the factors that controls or decides the skin depth for a given material and for a given frequency of the AC signal or AC current? So the general formula for obtaining that skin depth is as follows. So that is delta is equal to, right? So delta is equal to, right, rho by pi f mu naught is basically root of rho divided by pi f mu naught, right? So this is the uh, general relation to get the skin depth. So this is actually the resistivity of material. Resistivity of material. This is AC frequency, AC signal frequency or AC voltage frequency, right? So AC current frequency of AC current, the frequency of AC current, right? So the frequency of AC current, frequency of AC frequency of AC current. Okay, Then what we will do, we will just try to see other form of this, or we'll just know for if you substitute the constant values, that is the pi values and mu naught values, so this skin depth values will turn into the following relation. So that is, if you substitute the pi values and mu naught values, so uh, the skin depth can be written as pi point, right? So pi point 03, right, 03 into 10 power, right, 10 power 3, right, so root of rho divided by f. So we know that here this rho is the resistivity of the material, and f is frequency of the AC current, right? So this is the relation. So then we can also write this equation in different ways, right? Different ways, or connecting to different parameters. So what is that, we will see, right? So we know that rho is equal to, right? So we know, right? So what is this here? Mu, right? So mu is equal to mu r and mu naught, right? Mu r, mu naught, and delta is equal to, right, delta is equal to, here if you just take these mu naught values, right, so mu naught is equal to mu by mu r, right, mu by mu r, right. So this way I can write it as this, right. So basically this is little bit yeah. So we can write it as like this. And basically this relation can be also written as rho by pi f mu, right, rho by pi f mu. Then we can also write this as so delta is equal to rho by pi f mu naught can be written as this, right, so mu r mu naught, right. So right, so this is the relation for the delta now, right. So then what we will do next step, we will simplify this further. So by uh, substituting mu r is equal to 1, if you assume the mu r value, right, mu r value is equal to 1, our equation will modify into the following. So that means rho by pi times f, right, pi times f. So now mu r is equal to 1, therefore I'll write directly mu 0. This is how we get that relation what we have written as a in the first instant, right, or when you start this. So apart from that, right, so apart from that, we can also modify this relation, right, in different ways. We know that rho is equal to 1 by sigma, right. That means the resistivity is equal to 1 by conductivity. So I can just rewrite this delta values in a relation in the following way. If I substitute rho in place of rho, if I substitute 1 by sigma, my delta becomes 1 divided by sigma times f times pi times mu naught, right. So this is equal to root, this is root. Right, so this is root, and then this is the relation for our case. So we can also write this relation further in different ways. So we already know that this mu, right, the mu can be written as delta. So I'll just try to write this delta in different way. That is, we have f, right, so f can be written as or otherwise I'll just come back in this way, different ways. So we know that w, right, so w is equal to 2 pi, right, or 2 pi f, right, 2 pi f. So then what I will do, f is equal to omega by 2 pi. So this is the frequency relation, and I will substitute in this equation to get different version of the delta. So delta becomes now, right, so delta becomes now 1 by sigma. In place of f, I will be substituting omega by 2 pi, right, omega by 2 pi, and then I will multiply with pi and mu naught. right? So here you can put mu naught r, right? So you can put mu naught r, right? So here this in place of the mu naught, you can also put mu 0 mu r, right? Mu 0 mu naught mu r can be put. We have not put here because we assume that mu r is 1. If your the mu r value is not 1, we can substitute here mu r value as well, right? So then and this is the relation after substituting the frequency f values. Then what we will do, we can still rearrange this equation in and then get the final version. So this is cancelled. So what we will get now, that is we have here you know, this is delta is equal to so by 1 basically 2, right? So 2 divided by sigma omega into mu naught, right? Mu naught. So this is the relation that we get now, right? So this is the relation that we get now. So if you want to write this relation in terms of in terms of the resistivity, so you can write in place of this sigma, we can put 1 by rho. So therefore what will happen, 2 rho divided by omega mu naught, 2 rho divided by omega mu naught. So this way we can write it as write the sigma value, right? So delta value. So apart from that, what we can do also, right? So omega is equal to 2 pi f, not omega is equal to 2 pi f, yeah, omega is equal to 2 pi f. So now we can write this as the following, right? So delta is equal to, in place of omega, I'll just try to replace 2 pi f. So I can just revert back to the, in terms of frequency. So that will give me like root of, 2 rho divided by 2 pi f mu naught. So this is the final relation, we have it. So what we discussed so far is we can have this skin depth parameter connecting to various parameters that depends upon what are the parameters available to us. Based on that, we can rearrange this skin depth relation and solve for getting the these skin depth delta values, right? So based on this discussion so far, what we understood is that, so skin depth is basically, right, for high frequency small skin depth. So we will summarize the result what we have discussed so far. So high frequency, right, for high frequency small skin depth. So let me write over a small frequency small skin depth, small skin depth, small skin depth, right? So that means this is p, small skin depth. And next one is high conductivity, high conductivity, high, right, high conductivity, as usual, small skin depth, small skin depth, small skin depth. So then high permeability, high permeability, we have small skin depth, small skin depth. So then low frequency, right? So skin depth current. Okay, so this is the different cases, right? This is the different cases for our skin depth, right? Okay.